solve system linear equations using matrix method. You know the procedure. First you give this information, rewrite the information given as system linear equations in matrix form. So you write first the coefficient matrix, that is 2, 2, 1, 1, 1, negative 2, negative 1. And what are the elements in the third row? The coefficient of x is 0. So you have to take 0, 3, negative 5. Please remember. And then you write the variable matrix in column x, y, z equal to the constant matrix in the column. You get 1, 3 by 2 and 9. Now if I denote the coefficient matrix by A and keeping x, y, z and the column this constant matrix 1, 3 by 2, 9, keeping as such, multiplying both sides by A inverse, it may be rewritten as x, y, z equal to A inverse. Remember, pre-multiply, A inverse should be on the left. That is very important. A inverse times 1, 3 by 2, 9. Call it 1, and now it is just a matter of finding A inverse and replacing here. So what is your coefficient matrix? Coefficient matrix is 2, 1, 1, 1, negative 2, 1, 0, 3, negative 5. To work out A inverse, it is 1 by determinant A into adjoint A. So we have to first find determinant A. Otherwise also, let me tell you, because if determinant A does not exist, then we can't solve it. You know the equation. If determinant A comes 0, then there are two possibilities, that it may have no solution or many solutions. So in any case, you must solve the value of determinant A first of all. So let us work out determinant A first. Expand along R1, the first row. So you get, though I have not put the symbol of determinant here, it is the symbol of matrix, but we can work out determinant A as along R1. So you get 2 times, 10 minus 3, 10, it is delete the row and column through 2, so you get, just show me the question. Yeah, it is minus 1. Please make a correction. In the second row, it is 1 minus 2 minus 1. That's why I is not getting correct. Now 2 times, replace the row and column through 2, you get 10 minus plus 3, so you get 10 plus 3. And minus 1 times, delete the row and column through 1, you get minus 5, and through 1 you get minus 5. So minus 1 times, delete the row and column through 1, you get minus 5 minus 0, and the third element plus 1 time, you get delete the row and column, you get 3 minus 0. Work it out, you get 26 and plus 5 plus 3, that is 34. So finally the value of determinant A is 34. And now let us work out the value of adjoint A. Adjoint A, is the transpose of the cofactor matrix. Let me write C11, C12, C13, C21, C22, C23, C31, 32, 33. How do you work out? That delete the row and column through A11, and with the proper sign you write the value of remaining determinant. And proper signs you select according to this matrix: plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. So here you work out and you get transpose of it. So for one element, delete the row and column through 2, you get 10 minus plus 3, and outside I write plus. It is always better, I'll suggest that you write the proper signs and then work out the value of remaining minor. If you do both the work simultaneously, maybe you can do mistakes. So plus times in the bracket 10 plus 3. Then for the next element of the first row, it is minus times, delete the row and column through 1, you get minus 5 minus 0. And then plus times, delete the row and column through 1, you get 3 minus 0. So plus times 3 minus 0. And similarly, now I am writing, but you repeat the process yourself. It will be minus times minus 5 minus 3, plus times minus 10 minus 0, and minus times 6 minus 0. Then you have plus times minus 1 plus 2, and minus times minus 2 minus 1, and plus times minus 4 minus 1. Work it out, you get transpose of C13 and 5, 3, 8, minus 10, minus 6, 1, 3, minus 5. Now take the transpose of it. The elements of the first row, that is 13, 5, 3, you write in the first column. The elements of the second row, that is 8, minus 10, minus 6 in the second column. In the elements of the third row, 1, 3, minus 5 in the third column. So that is your adjoint A. Now what is A inverse now? A inverse is 1 by determinant A into adjoint A. Determinant A, how much we calculated? 34. So it is 1 by 34 times adjoint A. You have worked out 13, 8, 1, 5 minus 10, 3, and 3 minus 6 minus 5. And now replace this value of A inverse so obtained in 1. So from 1 we get the value of x, y, z equal to A inverse, which you worked out as 1 by 34 times 13, 8, 1, 5 minus 10, 3, and 3 minus 6 minus 5 multiplied by the constant matrix 1, 3 by 2, 9. And you multiply row to column wise, multiplying by the elements of first row to the column, you get 13 plus 12 plus 9. Then repeating the process with the second column, second row with the first column, you get 5 minus 15 plus 27, and then repeat the same with the third row, you get 3 and minus 9, 3 minus 9 minus 45. Just work it out. You get 1 by 34 times, add the elements in the first row, you get 34, 17 minus 51. Now multiplying each element by 1 by 34, you get 1, 1 by 2, and minus 3 by 2. On the left, you have a column matrix, a variable matrix XYZ, equating respectively the elements. You get x is equal to 1, y equal to half, z equal to minus 3 by 2 is the required solution.